Next concept to be discussed is total internal reflection. So till here we discussed about refraction of light, and also we see Snell's law of refraction. So this is also a phenomenon which is exhibited by the light, and that phenomenon is called as a total internal reflection. So we already know about reflection. So reflection means when a ray of light strikes a medium, then the light will come back to the same medium. Then that is known as a reflection. So as an example, if I say, if we incident a ray of light on a mirror, light will come back, and that process is called as a reflection. And here, what other words included is total internal reflection. This reflection is one total. So in the previous session, we know that when a ray of light is incident from rarer to denser, part of a light will reflects and part of a light will refracts. And in that case, the incident of light will split as a reflected and a refracted light. But in this phenomena, this will undergo only one phenomenon of light, which is reflection. That is why it is known as a total reflection, and it will occur internally. So, because of it, it is known as a total internal reflection. So, for the better understanding of this concept, I will use the animation over here.
Now we are experimenting total internal reflection using this animation. So to undergo this total internal reflection, the ray has to pass from denser medium into the rarer medium. So this is what you can see from this animation. So in this animation, we have placed this source of light in the denser medium, which is in the blue region, and we are trying to pass a ray of light from this denser medium into this air medium, which is a rarer medium. So now we want to see the another phenomenon of light, which is called total internal reflection. So the name itself indicates us that it is a reflection. So reflection means when a ray of light incident on any surface, the ray will come back to the same medium, and this phenomena, this process is called as reflection. But when we consider the two transparent mediums, or when we consider any one transparent medium, and if you are incidenting the light onto that transparent medium, then part of a light will reflected and part of a light will refracted. This is what you can see here. See, this is a part of light which is reflected, a part of light is refracted. That is why here the light, incident light, will split as a reflected light as well as a refracted light. So in this concept, it is a total internal reflection. It is also a reflection, but it is a total reflection. Then let's see what is the meaning of a total reflection. So this is the source, and here I am incidenting light at an angle of 10 degree. This is a 20, this is a 30 degree. As the incident light at a 10 degree, a part of ray will reflect at the same angle. A part of light will refract, which having an angle of greater than the angle of incidence. See, 10 plus something is there. That is the angle of refraction. Let us again increase angle of incidence, as we kept for 20 degree as an angle of incidence. Again you can see a part of light which is refracting and reflecting. Further, let us increase the angle of incidence. Now I placed incident ray at an angle of 30 degree to the normal. Again we can see reflected light and refracted ray, reflected light, but the angle of refraction is greater than this angle of incidence. Again let us raise angle of incidence. Now angle of incidence is 40 degree. In that case also we are getting the angle of reflection, and I mean a ray is refracting and a ray is reflecting. Again let us increase angle. See, you cannot see at this particular angle, we cannot see the refracted light. So this is happening only at a particular angle of incidence. So the angle of incidence here is, which is 50 degree, at which we are not observing the refracted light. So what's happening here is, all the ray which is incidenting on the surface is reflecting back to the same medium. So here is reflection is undergoing totally, because in all the initial cases we saw a refracted light as well as a reflecting light. We saw the refracted light, this was a refracted light, this was a reflected light, but at an angle of 50 degree we cannot observe the refracted light. That's why, so at this particular angle of incidence, the ray will totally reflected back into the same medium, and this is known as the total reflection. So this will happen only at a particular angle of incidence, and that angle of incidence is called as critical angle. See, this is the critical angle. So the critical angle observed here is 50 degree. Now let us see the intensity. See, this is a 100% intensity. Let's see in the refracted light. See, sorry, in the reflected light, here also we are getting 100% intensity. Now let us slightly vary the angle. So at an angle of 55 degrees we are getting only 79% in the refracted and only 20% in the reflected light. So as we increase angle at an angle of 50 degree, we will get 100% intensity. That means all the ray incident on this interface of the two medium will reflected back into the same medium, and this is happening when the ray is passing from denser to rarer. So this is known as total internal reflection.
This is what the picture we have studied in the animation. I have drawn the same picture over here. This is a denser, this is a rarer medium. So to undergo this total interreflection, the ray must pass from denser medium to the rarer medium. You can see this is the incident ray, which is incidentting at O1, and the part of light is reflects, part of it refracts. If this ray is incident at a point O2, again part of it reflects and refracts. When this ray is incident at a particular angle of incidence, at which the ray will which will traces the interface of the two medium. So this ray is incident at an angle which is called critical angle. At this point, whole ray will grazes the interface of the two medium. This is the interface of the two medium. So will pass along the surface of the two medium. So if the angle of is increased, which is greater than IC, then what will happen is ray will totally reflected back into the denser medium. So here ray is reflecting back to the denser medium, and this is happening particular angle of incidence, which is called as a critical, which is greater than the critical angle. So at a critical angle, what is happening is the refracted ray will pass on the interface of the two medium. So in that case, angle of refraction, see this is angle of refraction, this is angle of refraction, this is also angle of refraction. See this is angle of refraction where angle of refraction is equal to 90 degree. So this is the explanation for total internal reflection. So total internal reflection means when a ray of light is traveling from denser to rarer medium is incident at an angle greater than the critical angle, then the ray will completely reflected back into the denser medium, and this phenomena is called as a total internal reflection. See, internally it will reflect. For example, if this ray is again incident on this surface, and if the angle of incidence is greater than the critical angle, again it will undergo the again it will undergo the reflection. So the next part will be like this. So that is why if the ray is continuously incident at the angle greater than the critical angle, then this ray will undergo multiple reflection. That will not come out. It will undergo multiple reflection. So this reflection which will happen inside any conductor or inside the one medium. That is why it is known as the internal reflection, or it is called as a total internal reflection. Now let us apply the Snell's law for this, and let us apply the Snell's law at the critical angle. So before that, let's write the definition. Total internal reflection is definition. The ray of light traveling from denser to rarer medium is an incident at an angle greater than critical angle. Then ray is totally reflected back into the denser medium. This phenomenon is called total internal reflection. This is called total internal reflection. So this is the definition for total internal reflection. So I have also introduced term which is a critical angle or angle of it is a critical angle. So for the critical angle, what we got is the angle of refraction become 90 degrees. So this is we got only at rays incident angle of critical angle. So critical angle, let us define the critical angle. The angle of incidence for which angle of refraction is angle of refraction is 90 degree. That is what we got here. If the ray is incident at the critical angle, the angle of refraction we got 90 degree. So these are the definitions for total interreflection as well as for the critical angle. Then does it have any rules to happen the total interreflection? Yes, there are particular rules to undergo the total internal reflection. So let us write it. Let us write the conditions for total internal reflection. Does it have any condition? Let's see. Conditions. Conditions for total internal reflection. So see, in the beginning I told you, to undergo the total internal reflection, the ray has to pass from dense side to ray. That is the first condition. The ray must travel from denser to rarer. Ray must travel from denser to rarer. See, this total internal reflection undergo only when the ray is incident at an angle greater than the critical angle. See, for all other angles, we were getting reflected and refracted light. But even if it is incident at the angle of critical angle, then we got a light which grazes the interface of the 2 meter. But once we increase angle of incidence greater than this angle, then the ray is totally reflecting into the same medium. That's why angle of incidence must be greater than the critical angle. Second point is the angle of incidence must be greater than critical. So these are the conditions to happen the total internal reflection.